my presentation will give more clarity and hopefully give more ideas to you about the subject of blockchains, and in particular blockchains for a better society. So this is, the vision. Okay, so a important problem that we all have using the internet is trust. I mean, trust is a universally important problem, but one thing that we encounter every day, and that is trusting the people we're talking to on the internet, and in particular, websites that deal with important information. So the obvious example is banks. You might log into your bank account online, authorize transactions to go out, pay people, settle your credit card bill, or you might go online and put in important information regarding your date of birth and passport to an airline company so you can fly to the UK or wherever else. And there's a general concept here of receiving information from servers on the internet. Now, all the time you're also sending information to those servers, and it's really important that you know that the information that's coming backwards and forwards is the correct information you're receiving from the people online, and that the people you're sending the information to can be trusted with that information. So if it's a bank, it's really important that you know you're receiving your actual bank account status, and you are sending to the bank sensitive information, and you hope that it's really the bank that you're talking to, and not someone who is taking all of your bank details to log into your account later themselves and use your money for whatever they want to do. So, how can we trust that we're actually talking to the bank? And at the moment, it's all done via SSL certification. So you look for the padlock in the browser so that you can be sure that you're actually talking to the website, the server, the company that you think you're talking to. So if you ever type in your password and you haven't got the little padlock, you really need to change your habits. But how do we know that that padlock means anything at all? So that padlock in the browser says that the website that you've contacted has digitally signed that it is the website that it says it is. So you go to your bank, and your bank provides to your computer, provides to your browser, the digitally signed certificate that says, yes, I am ING Direct. So how do you know that that certificate has been signed correctly? Well, you download from the internet a list of people who themselves have signed off on people who can sign certificates. So there is a list of authorities who say, yep, this bank signed their certificates in this way. And that signature, authorizing the bank signature, is held in your browser on your computer. So when you contact your bank, you download the certificate signed by the bank. That signature is checked against a trusted signature authorization list, which itself is signed by the certification bodies. How do you get the signatures of the certification bodies? Well, you download them off the internet. So you can see there's a problem here. How do you know that you've downloaded the correct certificates in the first place? Well, it's okay because your browser has a list of certificates which authorizes the certificate authorizing signatures. Now, we could go on forever with this, but it's got to start somewhere. And it starts when you download your browser. So every browser that you download has root certificate authorizations in it. And when you download your browser, you just have to trust that those root certificates are correct. So if you were unlucky one day and you happened to download a browser off a server that was trying to scam you, then you would get a list of certificates which included a scammer certificate. And then at a later date, when you went to your bank website, that scammer could intercept and say, yes, I am your bank. And your browser would check against the list of root certificates. But because the root certificate that you had includes the scammer's root certificate, your browser would say, oh yes, this scammer is definitely the bank that you think you're talking to. And then you give your scammer all of your details, and that's a shame. So how do we get around this problem? Well, wouldn't it be nice if on the internet there was some platform, some technology, some way of having a single source of truth that gave to you what those root certificate authorities actually are? Yeah, okay, so blockchains. What are blockchains? So Rutger's done a very good job of explaining background to blockchains, but I'll just review it here. So, importantly, blockchain is a new technology and it allows new things. So one of the problems with new technologies is that as we try and describe what they can do, we try and describe them in reference to things that already exist. But of course, because it's something completely new, that's not entirely possible. So hopefully as we explore everything today, the new elements to everything that is possible with blockchains will come through. So The Economist has called it the trust machine, which is a good name because it reflects this idea that it is a source on the internet of actual truth, actual trust. And I like the machine bit because that's very technological. So trust machine, I think, is a good term here. The term machine is also important because machines process things. So a lot of what's being discussed in the blockchain world is not about processing. So Bitcoin, for example, isn't a processor. It's just a ledger. Now it does have some processing capability, but for historical reasons, those processing capabilities are almost entirely disabled. But as blockchain technology is being developed, and coming from ETHCore, I'm from a company that's trying to develop blockchain technology, and we have someone from IBM talking today who is also working on this. Lots of other people as well. But we need to move away from ledgers, so just trusted databases, to blockchain platforms that can process data. So take logical inputs, do a calculation on them, and give a trusted answer. Now, with this ability, and it comes from decentralization, which I'll come back to later, the important result is that we get superlinear efficiencies. So, as I said, it's a new technology, it can do new things, and often when we approach blockchains and ask, what can it do? And someone gives an example. Oh yes, it can process payments, it can authorize certificates, it can track assets, it can help with supply chains. If we look at just one example, then the question that comes up is, well, we can do that already, so why do we need blockchains to do that? And the answer is that with blockchains, we get a accessible platform which then allows connections between all of these different use cases, which at the moment, connections are not possible. So these efficiencies, I'll again come back to later. So let's just use Ethereum as the example. So obviously I'm from Ethereum, so I want you all to love Ethereum. But an example showing this cross usage, I'm going to have to come back to this because is using a taxi. Okay, so this is just to try and illustrate why blockchains, in particular trust machines, a blockchain that can actually process logic, is useful. So this is a standard situation, right? You want to get somewhere, so you go to a taxi, and then after some time, you give the taxi some money, and the taxi has given you a location. So that's a good exchange. You get a new location for some money. Now, when you get into the taxi, you don't actually know for sure that the taxi driver knows where they're going, whether they'll actually deliver you to your location. And now with sat-nav it's a bit easier, but now to generally see taxi drivers, particularly in capital cities, bringing up their sat-nav. Oh yeah, I don't know where that is. And they put in their address, and then they're trusting the sat-nav to take them there. And of course, they don't know that the taxi driver doesn't know that you can actually pay them. So there's often the problem, particularly at the weekend, late at night. Get in the car, oh yes, I'd like to go home please. Oh, sorry, I don't have any money. And generally people are nice and go to a cash machine and it's all sorted, but this is a risk that the taxi driver takes. So, if we have a escrow smart contract on a blockchain, then all of this can be dealt with automatically. So imagine a contract. So this is I call it a contract because that's the terminology that's used to describe apps that run on a smart blockchain. So a taxi escrow app. So you can have it on your phone perhaps, just like the Bitcoin wallets that we were showing earlier. And you can add into that app a deposit and your location. So at this stage, it sounds a little bit like Uber. So you can get up your Uber app and you can say, right, I want to go to this location. And of course, Uber has all your bank details, so payment is guaranteed. But Uber runs the Uber app. And here, we're talking about an app that runs itself. So there's no one overseeing this app. It's part of the trust machine, and so you trust that it will run correctly. And then as the taxi driver takes you to the location from your phone and from the taxi's GPS can be fed into this smart contract, so it can keep track of where you are. And then when you get to your location, automatically the smart contract will know that and can release the funds to the taxi driver. Now, if something goes wrong, so the taxi never takes you to the location, then the taxi driver will never get the payment. But the funds are in the escrow, so the taxi driver can be assured that if you are dropped off at your location, they will definitely get the funds. And this can happen completely automatically on the smart blockchain platform, with no need for any company to take responsibility for it. Now, the way that this becomes better than better than Uber, or real advantage to the way things work, is that the certification that this taxi driver is allowed to provide a taxi service can be provided and proved via the Taxi Escrow smart contract, the blockchain app. And again, this can be done automatically. So this app will not appear unless the certification proof that they're allowed to be a taxi driver is also on the blockchain. And the contract can also take arbitrary conditions to paying out. So here I've mentioned Augur, which is a prediction market, a source of external information on the blockchain. And so this blockchain app could provide information, for example, about the way that traffic is flowing in the city, to say, which routes are faster and which routes are slower. And this way, the app could reward the taxi driver with a greater fare if the taxi driver took a more efficient route. Now, at the moment, there's no way of doing that. So, you can't say what the most efficient route is given a particular amount of traffic. So, by putting it on the blockchain, the information can be there in real time and in a trusted way it can be processed to give the taxi driver more money if they took an efficient route, or less money if they took a particularly long or roundabout route. And all of this can happen completely automatically on the blockchain platform. Okay, so I've already talked about the trust machine. I'm just going to go back to these points here. So overall, blockchains are useful because they can increase accountability. So as we saw from that taxi example, you can, as a customer to the taxi, you can see that the taxi driver and the car that the taxi driver is driving have been certified. The whole route is recorded from GPS, and so that's accountable and auditable, because the payment that's made is also recorded on the blockchain. And all of this can be done automatically on the blockchain, and so the amount of paperwork and communication between departments and services can be reduced. So blockchains obviously are new technologies, so there's a lot that goes into them. I think that explaining in depth technically about how blockchains work is something that should be done outside this talk. So if you are interested on the technical side, then please come and ask me questions. But redundancy is an important part of blockchains. So the information that's stored on the blockchain is stored by many different servers. And it's this way that it can become a source of truth, because if you want to try and corrupt the system, you've got to corrupt everything on the system, which is designed to be nearly impossible. And of course, the cryptographic signing procedures, which provide the mathematically provable, secure ways of identifying everything that goes on the blockchain. And this way, we have truth and we have accessibility. And it's these two things together which I think really give the strength. So let's just have a look at another example. And brainstorming with work before this, we thought that perhaps being a student was a good example for where we can see the efficiencies and gains. So if you're a student, then you're quite keen to get a student loan, and the student loan company needs to know that you've enrolled at a university, and as you progress through university, the university needs to report to the student loan company what your performance is, and you need to deal with both of these as a student to receive the money and pay back the correct amount. Now, as a student, you obviously need accommodation, so you will deal with landlords, and the money that you get from the loan will go towards your landlord's income. And in the far future, we can conceive of a system using the blockchain where it's quite easily possible to say that your student loan can actually only be used for particular things. So you're not allowed to use your loan to buy alcohol, for example. Now, in the UK at least, to be a student landlord, you have to be certified as such. So landlords need to report to the local authority, and then the local authority needs to inform students about which landlords will give them acceptable accommodation. And in order to be a certified landlord, then the accommodation needs to be certified for the heating and plumbing, for all of the electricals. In the UK, it's really important that all of the furniture is fire retardant. So about 5 years ago, landlords had to throw away all of their furniture and buy new fire retardant furniture. Of course, electrical certification itself includes both the appliances, depending on the level of the accommodation. If it's actually inside a university, then the appliances themselves have to be tested, but at least all the wiring has to be signed off by certified authorities. Now, how do we know that the fire retardant furniture is actually fire retardant? Well, fabric suppliers certify that they've used the correct materials. It's of course electricians and appliance testers that test all of this. Electronic manufacturers also certify that their goods are correct. But the fabric suppliers need to get a sign-off from the correct body to say that they're actually using the correct materials. The national trade authorities, they're the ones that check that the electronics manufacturers are complying and that electricians are correctly trained and appliance testers are doing the correct thing. And of course, all of this comes back to the government eventually, and we see that we have an incredibly complex web of interaction. And this is a real-life paper version of the SSL certificate problem that we were talking about at the beginning of this talk. So in the digital space, things tend to be a bit easier because digital information is easier to move around than actual physical goods. But nevertheless, we live in a physical world, so we need physical goods, and so we need these physical interactions to make sure that everything is going according to plan. If we use a blockchain, then everything can just refer to the blockchain process, the trust machine at the bottom. So the student loan company can just put a smart contract onto the blockchain platform that says, in order for a student loan to go out, these are the conditions. Just like in the taxi example, in order to pay the taxi driver, the certain conditions had to be satisfied. The student can go to the blockchain to say, right, I am going to go to university. The university can use the blockchain to accept students' admissions and sign them off as necessary. Landlords can simply, again, use a smart contract, and all of these various bodies that need to sign off on a landlord can do so without having to ever interact with the landlord, because everything can just go through the trust machine in a unilateral way. So this simplification is where I see the real benefit, because if we add a new constraint, so we see that, for example, electricians, it isn't enough for them just to be ticked off by the National Trade Certification Authority. It's actually that electricians need to get certification from a recognised university degree. Then we don't need to add a new connection here, because we can just use the existing connections with the blockchain. And if new regulation comes in, which means that an extra body or an extra type of person needs to start doing a new type of work, rather than connecting to all of the different vested interests, adding a new entity here is just a case of connecting them to the blockchain. And so it's this way that we decrease the marginal complexity as we make the system bigger. And this is the key, I think, for society. You know, as we become more advanced as a society, we need to do more things, and the existing solution is to use more resources. But of course, resources are finite. So how do we match the exponential growth of society with only finite resources? And the answer is to make it so that as we add more things, the cost of adding them gets less. I've got 4 minutes left. Now, I mentioned that I'd just say about decentralization. So decentralization is a really important part of this, because the decentralization is where the system is administered not from any central point, but from all points simultaneously. And it's that which allows people to participate directly without having to always register with some central authority. They can just join in the system, and the conditions for them joining are imposed automatically, and if they don't fulfill those conditions, they can't join. So there's no possibility of imposters getting into the system and using it incorrectly. That is just simply not possible. So this is my sort of nerdy way of summarizing this. Wherever we need outcomes that are conditional on many, many different inputs, so things being certified, money being paid, certain data being available, events happening, all of these are conditions for a certain outcome to happen. But that needs to happen in a asynchronous way, i.e. all of those different conditions aren't going to come together at the same time, or making all of those conditions come together at the same time is incredibly expensive. So buying a house is always really annoying, particularly in the UK, because everything needs to happen on a single day. So everyone needs to be pretty much in the same room with all the documents, the money ready to go, the bank involved, the solicitors involved, all the buyers. And if there's many people in a chain of house purchases, the chances of something going wrong is actually very high. But if we can make all of that complexity happen without it needing to be at the same time, which is possible with smart blockchains, then again, we have a win. All we need is the ability to process logic, a truthful state of affairs that's updated over time, and representation of identity, which is where the e-Estonia, e-residency of Estonia comes in. These two, the logic and the state, they are provided by smart blockchains such as Ethereum. So we have the 3 pillars of what we need for blockchain society, as I'm going to call it. Identity, representation of assets, and flow of data. And in an abstract way, with these 3 things, then we can build whatever we want. Okay, thank you very much.
Thank you, Aeron. Aeron, you started with speaking about monitoring the supervisor, and the supervisor should be monitored, and so on.
Yes, that's a good way.
Gee, how difficult can you make everything? But it's already, well, it is like it is, and we have to deal with it. But then again, later you gave some examples about what the possibilities were. Are they already in progress? Are they already operational, or is it just the idea we have the idea how it could work? For instance, the landlord and the story about it, and the taxi and the story about it. Where is it working right now, and where is it operational?
Right. So, just to follow up on your initial comment, who supervises the supervisor? And of course, this is a problem we've had for a long time, and it's led to democracy to try and spread out the final supervisor's role as much as possible. But ultimately, what the blockchain does is it makes it so that the supervisor at the end of the chain, the supervisor who's doing the supervising, is supervised by everyone who is being supervised. And at the same time,
knows exactly what you mean.
And at the same time, isn't supervised by anyone. So this is the sort of beauty of how it works in a sort of lovely recursive way.
Well, then the second question then.
So, is it working? Yes. So at the moment, Ethereum is the only smart blockchain that's actually running, and it's been running for 6 months. It currently holds almost $1 billion of value in the harshest digital environment ever known, which is the internet. So, yeah, the platform is working. You can't yet pay for your rent through the Ethereum platform, but give it time.
You're working on it.
Yeah.
Okay, vragen aan. Ik heb meerdere vragen in de zaal.
Thank you very much for the presentation. I'm really curious on the practical side. For Ethereum, it's now 6 months in business, I've just learned.
Yes.
But who are hosting it? I mean, it's a decentralized system, but are there just peers like us? Or are there different contracted companies which have the hosting? I mean, if we would like to translate this, for instance, to the government, would we want every Dutch citizen or every world citizen to be a part of the blockchain? Or would we want the different institutions to be part of the blockchain and do the calculations, the hashes, etc.? How would your views be on Ethereum and for government?
So that's a great question, and it has 2 parallel answers. So the first answer I'll give is with regards to the public Ethereum blockchain. So the public Ethereum blockchain is the one that's running. It can process smart contracts, so it can actually do all of the things that I talked about, but no one's written those apps yet. And ideologically, the answer is yes, I want everybody in the world to be running and contributing to the operation of the Ethereum blockchain. And that's possible. So decentralization, allowing that unilateral participation, means that everyone can. But this is impractical in the sense that most people don't care, and that's fine. Right? It's up to anyone who wants to participate. Just like voting is open, and unless you're in a country like Australia where it's against the law not to vote, you can choose whether to participate or not. And if you don't care, that's fine. You don't vote. But if you want to vote, you can have your say. So it's very much like that.
Okay.
And more practically speaking, yes, I think that as we progress, it will be the institutions and the more concerned citizens who do most of the work in keeping the system running. So just to quickly address the second parallel way of answering this question, there doesn't need to be just the one public blockchain. There can also be private blockchains and governmental blockchains and any other setup that you want. And so if the Dutch government wanted to get ahead with this, then without going to the public blockchain to start with, then using servers or commissioned service providers, you could run your own blockchain and then invite Dutch citizens to participate themselves.
Because of the time. Just one question left.
Yes, thank you very much. I would really like to hear some words or emphasis on adding non-logical context within scope of adding blockchain platform capabilities. Because from a governmental point of view, our biggest concern is how to add context in the design of our solutions instead of running the logic.
So, if I understand it correctly, you're asking about not just having logical conditions that have to be met in order to achieve outcomes, but also bringing in more contextual information.
It's the non-logical point of view of the world we need to govern from a governmental perspective. So care about people instead of having financial transactions being transferred.
Yes. So that's the beauty about moving from Bitcoin, which is just the first use case that was thought of for blockchains, and in fact the simplest one possible, to the smart blockchain with smart contracts such as Ethereum, where anything that can be run on a computer can be incorporated. So it's beyond just thinking about transactions. We can bring in absolutely everything, and it can also incorporate the wisdom of the crowd. So if you want to bring in information that is not readily processed as as numbers or data feed, but you want to gather opinions, then that is also completely possible.
Hans, ik ga het toch niet grijpen. Je mag straks in de pauze, want anders lopen we er
veel uit. Nee, dat komt eigenlijk, wij zouden om 11:15 even pauzeren. Ieder een kop koffie, dus we bewaren hem zo meteen heel eventjes. Ik wil een warm applaus voor Dr. Aeron Buchanan. Thank you.